So we're going to refer to sequences C and I from class today. So this is sequence C, the one that was 0, 1, 4, 9. And sequence I was 8, 2, 0, 2, 8, 18. And first of all, it says, how are these two sequences similar to each other? Well, if I look at the first one, I'm starting with 0 and then jumping to 1 and then to 4 and then to 9. One of the things I see is it is an increasing sequence, right? I'm going up by a certain amount. But the amount I'm going up by isn't the same. The amount that I'm increasing by is changing over time. And if I look at it, let's see, from 0 to 1 is a jump of 1 unit, and then from 1 to 4 is a jump of 3 units, and then from 4 to 5 is a jump of 5 units. So I went up by 1, then I went up by 3, and then I went up by 5. And if I look at the difference in those differences, actually this is something I've tried before. If I look at it, it's going up by 2 and it goes up by 2 again. So it's kind of roundabout, but what I could do is 0, 1, 4, 9. It goes up by, their differences are 1, 3, 5, and then the differences above that are all 2. So I know that the next difference would be 2, which would mean that this next value should be a 7, which means that my sequence value should probably be the number 16. So it is increasing, but the amount that it's going up by is different. In I, there's something kind of similar, going on, except it's not going up the entire time. It looks like it's decreasing and then increasing. But let me write that sequence out. So I've got an 8, 2, 0, 2, 8, and then an 18. When I look at the differences between those, I've got, this is going down by 6, right? 8 minus 6 is 2, and then this is decreasing by 2, and then at this point it increased by 2, and then it increased 2 plus, that's interesting, this is now increasing by 6, and then the next time it's increasing apparently by 12. So let me look at the differences. Is that 12 actually? Let's see, 18, 12. Well, that's actually 20. This is actually increasing by 10 right here. It went up by 10. I think, yeah. 8 plus 10 is 18. So if I take a look at the differences in between those differences, what numbers do I have? Well, let's see. The first thing I have is from -6 to -2 is, that's actually adding 4 units, right? It went up by 4. Yeah, it did. It increased by 4 from -6. -6 plus 4 is -2. And then actually from -2 to 2, that is increasing by 4 also. And from 2 to 6, that's increasing by 4. And then from 6 to 10, that's increasing by 4. So it's not that they have a common difference, but there's a common difference between their common differences. So it's kind of sitting out there. So I guess I'd say both I and C are increasing by changing amounts. I is actually decreasing for the first two terms, however. And then the changing increase, decrease values are changing at the same rate. So I'm showing those up here in the blue one, right? If you look at these blue numbers, these are all changing by 4. And these up here were all changing by 2. And I could extend the pattern this way, right? If I wanted to figure out the next one after the 18, I'll use black right here. So I could add the 4, which would give me a 14 here. And if I have 18 plus 14, that's a 12. I would get a 32. So it appears that I have some ability to extend these patterns, but they're a little bit more complicated than just adding the same value each time or multiplying by the same value each time. There's something else at play. The last thing that they point out here is the number sequence in part E of problem 42 is called the Fibonacci numbers. They are named after the Italian mathematician who discovered the sequence while studying how fast rabbits could breed. Interesting, going back to the very beginning of this chapter. What is different about this sequence from the other ones that you discovered? Well, I think almost all of you, when you looked at this sequence in class today, were very much perplexed by what's happening here. Because a lot of you tried to add 1 or add 2 or add different things, but it didn't seem like it really behaved well. I think a couple groups, maybe in period 1, maybe one group in period 1 and one in period 2, pointed out something. If you look at any value in this sequence, for example, this value 2, it appears to be the sum of the 2 that are before it, right? So 2 is 1 plus 1. And that works for all the instances we see here. So if I look at the 5, right, that's the sum of the 2 values before it. 2 plus 3 is 5. If you look at this 8, the 2 before it are 5 plus 3. 5 plus 3 is 8. So it appears that if you take the 2 previous terms, add them together, you can get the next term in the sequence. And if that holds to be true, right, the next value would be 5 plus 8 or 13. And then you could extend from there.